Hello, I'm Ali Kaste. I'm here to teach you about LS brand servo systems. So in today's lesson, we'll introduce the different types of LS servo motors and drives. And then we'll also talk about the applications of servo systems in industry. A servo system, in its simplest form, consists of a drive and a motor. We connect the motor to the drive, and through the drive, we can control the motor's movements. These servo systems have a lot of applications in industry, and we'll get to know some of the most important uses of servo systems shortly. One of the most important applications of servo systems is in robotic arms and their movement. As you can see, a robotic arm can perform very precise movements for us. In this image, as you can see, our robotic arm is made up of two motors, each of which is separately connected to a drive that controls its movement. Another application of servo systems in industry. It operates in speed mode and position mode, both of which can provide us with very precise movements. Another application of servo systems in industry is in CNC machines, where we can use servo motors and drives for extremely precise movements, as you can see in the image. Here, we use a servo motor for cutting wood, which can perform extremely precise movements. Well, in this image, you can see different types of servo motors, and later on, we'll get more familiar with the internal structure of these motors. Alright, this shows us a servo motor. At the end part of the motor, an encoder is used, which we can use as feedback, and it can inform the drive about the position of the shaft and the motor. And in this image as well, you can see the internal components of the motor. And as you can see, this servo motor can provide us with extremely precise movements. Alright, here we're going to get familiar with how to read the codes on servo motors. All LS brand servo motors start with APM at the beginning. The next letter indicates the type of motor shaft. If the letter S or L is used, it means our shaft is of the solid type. If the letter F is used, the shaft is flat, and if the letter H is used, it's called a hollow shaft model. The next letter indicates the flange size, and depending on our needs, we can choose one of these models. The following letter relates to the input voltage of the motor. If the letter P is used, it's a three-phase 400-volt motor, but if nothing is used, it's a three-phase 220-volt motor. The next part refers to the motor capacity. In the LS brand, we have capacities ranging from 30 watts up to 15 kilowatts, and depending on our needs, we can choose one of these models. The next letter indicates the motor speed, which ranges from 3000 RPM to 1000 RPM, and we can select one of these based on our requirements. The next letter indicates the type of encoder used in the servo motor. In servo motors, usually two types of encoders can be used: incremental encoders and absolute encoders. So if the letter used here is from AT, It indicates that our encoder is of the incremental type, and the difference between them lies in the accuracy and resolution of the encoder. The last three indicate absolute type encoders, which themselves come in two models. They have single-turn and multi-turn types. Absolute single-turn encoders can only determine the shaft position for us. But in the multi-turn type, in addition to being able to determine the position, it can also tell us how many turns the servo motor has made. One of the most important differences between incremental and absolute encoders is when the power to our motor is cut off. If the power to our motor is cut off for any reason, those models that use incremental encoders will no longer retain the position for us. But if we use an absolute encoder and the power to our motor is cut off for any reason, it can store the current position of the motor. And that's thanks to the battery that's added to their cable. Alright, the next letter indicates the end of the shaft. If the letter N is used, the shaft end is flat, but if the letter K is used, it has a keyway. This can be really helpful when we want to couple it with another device or, for example, use a gearbox. And finally, if we use the number 1, our motor doesn't have a brake and only has an oil seal. The oil seal actually protects our motor against oil leakage. If we use the number 2, our motor has a brake, and if we use the number 3, our motor has both an oil seal and a brake. Let me point out that the difference between motors with brakes and those without is that motors without brakes have a shaft that is normally free. But motors that have brakes, their shaft is normally locked. So, in situations where the power to our motor might be cut, if our motor has a brake, the shaft is locked and doesn't move at all, which can really help us in terms of safety. Well, in this image, as you can see, it shows us a servo motor, with this part being the motor flange and this part being the motor shaft. And this is also an image of hollow shaft motors. In this image as well, it shows us servo motors, and this part is the shaft. This part corresponds to the flange. This part is for the power cables, and this part is for the encoder cable. And this end part of the motor is for the encoder that is mounted on the motor. Well, this image shows us the servo drives that we're going to get to know the different types of in the next section. All servo drives from the LS brand start with L7. The next letter indicates the type of drive. If the letter S is used, it's the standard type. If the letter N is used, it's the network type, which relates to the EtherCAT network, and if the letter P is used, they're called index drives, which we'll get to know more about in future lessons. The next letter indicates the input voltage of the drive. If the letter A is used, our drive is three-phase, 220 volts. But if the letter B is used, our drive is three-phase, 400 volts. The next number indicates the drive's power. In the LS brand, we have power ratings from 100 watts up to 15 kilowatts, and depending on our needs, we can choose one of these. The next letter refers to the type of motor encoder that we can connect to this drive. If we use the letter A, We can only connect motors with incremental encoders to this drive if we use the letter B. We can only connect motors with absolute encoders to this drive. And if we use the letter U, we can connect all motors, whether they have incremental or absolute encoders, to this drive. The very last letter in the model designation is also a viable option. If you are looking to purchase several drives from LS and you happen to have a very specific option in your mind, you can certainly add that particular option to the drive, and we can then add it at the very end here, making sure it is included. Well, this image shows us the diagram of a motion control system. As we mentioned before, a servo system uses a drive, a motor, and an encoder. The encoder provides feedback and can send feedback to our drive, letting the drive know the position of the motor. In servo systems, we use a controller, and this controller can control our drive. For example, suppose we used an S-type drive. This controller can be a pulse generator, creating pulses, and based on the pulses it generates, it can send them to the drive. Since the drive is connected to the motor, it can control the type of movement as well. And let me also point out that here we can use different controllers for a servo system, one of the most important of which can be a PLC. And besides the PLC, we can also use other controllers to control our servo system. Alright, next we'll take a look at a motion control system together. As you can see in the image, here we've used a motor that's connected to a drive, and our drive is connected to a controller. That controller generates a signal and sends it to the drive. As you can see, it sent a signal to the drive. The drive then sends the signal to the motor. The motor starts to move, and from the encoder at the end of the motor, we can get feedback. As you can see, the feedback is sent to the drive, and the drive can monitor the motor's movement. Based on the feedback it receives, we can achieve very precise motion. Thank you for your attention.